Section 11.3 homework help. I'm going to take a look at 3 problems to help you out today. The first one's going to ask you to find the unit vector that's orthogonal to vector u and vector v. I'm also going to ask you to find the area of a parallelogram that has the vectors u and v as adjacent sides. And then we'll look at finding the volume where you have 3 adjacent edges, u, v, and w. Alright, so looking at the first one, find a unit vector orthogonal to these 2 vectors. And you have to remember from our notes that when you find the cross product, that is going to give you a vector that is perpendicular to both of those. So what I want to find is I want to find u cross v. So I'm going to go ahead and do that, and just have to remember exactly what that's going to do. That means that I set up my determinant where I have I, j, and k, and then vector u, since u is first here, is going to be 1i, negative 2j, 2k, 2i, negative 1j, and negative 2k. And now I just need to find the determinant of this matrix. So it depends on how you want to do it. If you like doing the arrow thing like I like doing, that's fine. If you want to expand it by row or column, that's fine. I'm going to do the expanded by row or column just because we'll do this a few times, so I'll do a couple differently. So if I expand by row or column, if I block out I, the row and column, I have negative 2, 2, negative 1, negative 2 for my matrix left over. So I'll still have to find the determinant of that. Next I would have j. Now remember that j is in the first row, second column. That means that it's going to be minus j instead of plus j. Remember that if I expand it, it should look like this. It would be I times the cofactor row 1, column 1, plus j times the cofactor row 1, column 2, plus k times the cofactor row 1, column 3. And anytime this adds together to give you an odd number, you switch the sign. That's why it's negative j. Alright, so if I block out the top row, block out that middle column, I'm left with 1, 2, 2, negative 2 if I block that out. And then it would be plus k times, block out this one, it would be 1, negative 2, and 2, negative 1. And now finding the determinant of these, it's going to give me 4 minus a negative 2. So I end up with 6i minus, well, at least minus j for right now. Find the determinant, it's going to be negative 2 minus 4, which is negative 6, so that's going to turn into plus 6j. And then if I find the determinant here, I've got negative 1 minus, looks like negative 4, or that's going to turn into a positive 3k. So this vector is orthogonal to both of those two, or it's perpendicular to both of those two. They're also asking me to find the unit vector. So that means I need to find the length of this. So now if I look for the magnitude of that vector, I'm going to call this vector w. If I look for the magnitude of vector w, it is going to equal the square root of 6 squared, or 36, plus 6 squared, or 36, plus 3 squared, or 9, and that's eventually going to give me the square root of 81, which I know is 9. So I need to divide all of these by 9. So my unit vector is going to be 6 divided by 9, or 2/3 I, 6 divided by 9, or 2/3 j, and 3 divided by 9, or 1/3 k. And that is the unit vector. So this vector is orthogonal to both of those. This one's orthogonal, and it is a unit vector. Now if you mix these two up and you put v in this spot and u in this spot, not much is going to happen other than that your signs will change, but it's still orthogonal. Doesn't matter if it's going up, down, whatever direction it's going. If it's going the complete opposite, it's still going to be perpendicular to it. Alright, so next problem says to find the area of the parallelogram that has the vectors u and v as adjacent sides. And of course, one of the things that we have written down in our notes says that the area of a parallelogram is the magnitude of the cross product. So I need to find the cross product of u and v just like I did for the last problem, and then I need to find the magnitude of it. Alright, so basically if you went back to that last problem, when we found this number, that would be the area of it. Alright, So let's go ahead and find the cross product again. So U cross V is going to equal the magnitude of I, J, K, 4, -3, 2, 5, 0, and 1. And now I'll do the little arrow thing for this one. Again, do this lightly. So if I draw the little arrows here, okay, apparently the pen's not going to cooperate. I'll do this lightly here. Hard to see it here. This is going to give me -3I. K times 0 times 4 is going to give me 0. 2 times J times 5 will give me 10J. So this is -3I plus 0J, 10J plus 0K. There's the first one. Minus, now I got to go the other way. It's going to give me -15K. 2 times 0 times I is going to give me 0I. And 1 times 4 times J should give me 4J. So it's 0I plus 4J minus 15K. And now when I add all these together or subtract, I'm going to end up with -3I, 10J minus 4J, so plus 6J, and 0K minus the -15, so positive 15K. That vector would be perpendicular to both of those. Since I'm looking for the area, I want to know the magnitude. So this is U cross V. Now I need to find the magnitude of U cross V. So it's going to give me the square root of -3 squared plus 6 squared plus 15 squared. Or if I add those together, I'm going to get the square root of 270. And if you're asking if that's something that can be simplified, I see it's got 27 in it. So I know 3 goes into that twice. 3 goes into that 3 times, so it'd be 3 times 3 times 3, and then times 10. So I know that 2 3's can come out. So that's going to give me 3. None of those have a pairing, so I multiply those back together. It would give me 3 square roots of 30 would be the area, or same thing as square root of 270, just not simplified. So when you look at these two problems, though, it's important that you look at what they're asking for. Unit vector, area. Look how we did the same thing. Exact same steps. We found the cross product to get this vector. We found a cross product to get this vector. Here we found the magnitude of it, and then that was the final answer when I wanted the area. When I wanted the unit vector, that's technically the area, but then I divided the vector by it. So you're doing basically the same thing. It's just your final answer is a little bit different. Alright, the last one is finding the volume where I have these 3 adjacent edges. And of course that means I go to the triple scalar product. And one of the rules that we learned is to do the triple scalar product. That just so happens to find the volume. So I just need to find the triple scalar product, which is represented like this. And so U is out here first, so I'm going to say that this is 1I, 4J, -7K. V is next here, so 2I. There's no J's, 4K's. And W's last, there's no I's, -3J, 6K. And all I need to do is find the magnitude, or sorry, the determinant of this matrix. So again, I like doing the arrow thing, so I'm going to do that. This is going to give me 0. 4 times 0 is also going to give me 0. -7 times 2 times 3, that's 21 times 2, so 42. So the volume is going to be 42 minus, now go the other direction, 0 when I multiply 0, 0, and -7. If I take 6 times 4 times 2, that's going to give me 8 times 6, or 48. 3 times 4 times -3 is -12, times 1, -12. Adding those together, I get 36, and 42 minus 36 is 6. That is the volume of that object. Overall, the idea is very simple. If you remember how to find determinants, you notice all we're doing is spending a lot of time finding determinants. It's just depending on what they're looking for. If it's volume, you should have nothing but numbers in here. If it's area, you should have I, J, and K, and then numbers. And if it's a unit vector or something to deal with orthogonal or perpendicular, you should again have I, J, and K. So overall, I think the section is easy. The material, it's just knowing what to do for what problem. There is your homework help for 11.3.